Welcome students, welcome to AIPMT 2016 Solutions by Nivedita Classes. Now we will discuss question number 25 of subject physics from code Z. What our question says that a capacitor 2 microfarad is charged fully using this battery of voltage V. And then what we did, we changed the position of the switch towards this side, and then some of the charge accumulated on this capacitor get transferred on the other capacitor, and we have to find that in this transfer of charge how much of the energy has been dissipated. So let's first find what will be the value of the energy when the switch is in condition 1. So the total energy will be stored in our 2 microfarad capacitor, and the value will be equal to half CV square. So initial energy we can say is equal to half, what is the value of C? It is equal to 2 micro, okay, V square, okay. So it is equal to basically V square multiplied by 10 raised to power minus 6. Clear? Now, if I talk about the charge, how much charge it will have, the charge is given by Q is equal to CV. So I can say that the initial charge which will be accumulated here, the initial charge that will be equal to 2 microvolt, this is micro V coulombs, right? So this is our value of charge. Now when the position is changed to switch 2, the total charge will remain same. Some of the charge will go to the other plate of 8 microfarad, but we have to remember that the voltage across these two capacitors will remain same. So let us say that this has a charge Q1 and this has a charge Q2. To voltage be same, we have to say that Q1 divided by C1, that is our voltage, let's say V dash, that will be equal to Q2 divided by C2, or we can say that Q is directly proportional to C. So the charge will get distributed between these two capacitors in direct proportional to their capacitance. So we have total charge of 2 micro V. So if I distribute it, Q1 will be 0.4 micro V and Q2 will be equal to 1.6 micro V. Okay. So if I talk about the final energy will be equal to, we can say Q1 square divided by 2C1 plus Q2 square divided by 2C2, and putting up the values we will have 0.4 into 10 raised to power minus 6 square V square divided by 2 into 2, we have 4 into 10 raised to power minus 6 plus 1.6 into 10 raised to power minus 6 square V square divided by 8 into 2, 16 into 10 raised to power minus 6. Okay. So if I solve for EF, what we have V square common into 10 raised to power minus 6 common. Okay. And I can also see that division by 4, that is also common. And what we are left with, 0.16 plus, we have taken 1 4 out, so we will have 0.64. Okay. Okay, so if I add these two, so it will be equal to 0.8 V square into 10 raised to power minus 6 divided by 4, that is equal to 0.2 V square into 10 raised to power minus 6. Clear? Now if I talk about what is how much energy is left in terms of percentage. So percentage energy left, that will be equal to EF divided by E initial multiplied by 100, right? So putting the values 0.2 V square into 10 raised to power minus 6 divided by V square into 10 raised to power minus 6 into 100, this is in terms of percentage. So V square into 10 raised to power minus 6, V square into 10 raised to power minus 6 gets cancelled out. So we are left with only 20% energy. Or we can say that percentage energy which has been dissipated during the process, that is equal to 100 minus 20, that is 80%. So our option 2 is our correct choice. Clear?